Greetings and welcome. We're taking a look at last night's homework, also found on page 856. So this is our second video on this page, but it was the second day. So looking at probability and odds. Don't forget them odds. So of 27 students in a class, man, I remember when my classes were that big. I don't envy that day. 11 have blue eyes, 13 have brown eyes, and 3 have green eyes. If 3 students are chosen at random, what are the odds of each event occurring? So, for problem 31, they say 2 have brown eyes and 1 has blue eyes. So, the probability 2 brown, 1 blue. Well, how many students have brown eyes? Actually, we'll start with that. It's 13, and I'm selecting 2 of them. How many students have blue eyes? 11, and I'm selecting 1. And then I'll put that over the total number of students, which was 27, and I was selecting 3. So this is going to find our probability, but remember that it's not the question they asked us for. Combo 13, 2 is 78 times 11 is 858. Over 27 combo 3, combo 2925. So 858 over 2925 reduces to 22/75. So this is the probability, and we want the odds of the same event of 2 brown, 1 blue. So that's going to be 22 over, this denominator was S plus F, this is the value of S, I want just F, so I'll do 75 minus 22 and get what, 53 sounds to be the right one. So there's 31. 33, only 1 has green eyes. Okay, so that's an exactly 1 has green eyes. So let's find the probability first. 1 green. All right. So how many had green eyes? Was it 3? And then I'm still selecting 2 other students, and I have to ensure that they aren't including the other green-eyed kids. So how many non-green-eyed students are there? 24, right? That concept right there, you guys are doing pretty good. Over combo 27/3. So this is going to be 24. Combo 2 is 276 times 3 is 828 over the same denominator of 2925. And I believe I can reduce that. 92 3/25. And that's damn near probability. So to find the odds of 1 green, I would subtract 92 from 325, and I do in fact get 233, as the answer indicates up above. So bam, not bad, not bad. I do like these problems that require you to know more than just your original assumption, right? I can't just count how many ways I could select green-eyed students. I had to figure out where these other 2 were coming from. That is very good thought process. I like it. Let's see, 38. Ken Griffey Jr. Man, I wish I pulled up a picture of what his baseball card looked like. At one point in the 1999 season, this book is so old, but it's fine because the math we're learning is hundreds, if not thousands of years old anyway, so we're cool. Man, I was probably playing Pokemon Blue back in 1999. So he had a batting average of .325. What are the odds that he would hit the ball the next time he came to bat? So .325, that's like the probability, if I'm correct. Someone with baseball knowledge help me. Probability of bat, right? That's what that means. He's been hitting 32.5% of, right, and not just hitting, but taking a base. Correct? Awesome. Excellent. I know something. So 3.325 is the same as 325 over 1,000, if you want to, right? Because that's 325 thousandths. So I could reduce that frac. It reduces to 13/40ths. So there's the probability. So the odds of getting a bat or at bat, I don't know how to phrase that. I don't know how to use that in a sentence. That he would hit the ball the next time he came to bat. Well, it would be 13 out of do 40 minus 13 is 27. So that's the odds. Yeah, it's not terribly difficult. Well, that's fine, that's fine. Let's look at one more problem. I think I've got time. Oh yeah, tenemos mucho tiempo. Security. Problem 39. Kim uses a combo lock. Oh, don't let that word deceive you. Oh, no. There we go. Lock on her locker that has 3 wheels, each labeled with 10 digits from 0 to 9. The combination is a particular sequence with no digits repeating. What is the probability of someone guessing the right combination? So, okay, well, first of all, okay, so, man, the denominator here is going to be a little bit tricky. Well, only one sequence is correct. So the probability of a guess, actually, wait, probability of guess on first try, I'm guessing. Right? If they allowed the person to just stand there and guess all day, that would change the probability. So there's one way for them to get that right. The denominator is going to be a little bit trickier. Let's see, there's 10 numbers, 10 digits, and I'm picking 3 different digits. So I could set this up as a combo, actually, wait, oh, permutation, right? I could do permutation 10-3 for the denominator. Or you also could have set that up as 1 over, well, there's 10 options for the first slot times 9 options for the second slot times 8 options. If you do kind of the hangman style, this is going to end up being the same thing. So all of our combinatoric skills are coming back. So that's going to be 720. All right. Let's see, B. If the digits can be repeated, what are the odds against someone guessing the combination? So we'll say probability, no guess. Right? So it's still, well, ooh. Well, let's figure that out in a second. If the digits can be repeated, then 10, 9, 8 would not be that. It would be 10 times 10 times 10, right? Or just 10 cubed, right, is the number of ways that could happen, which is going to be 1,000. All right? Now, that's the total number of ways it could happen. How many ways out of that 1,000 are correct? One of them. So how many are incorrect? 999. Right, so the way I could have found this number is I could have done 10 cubed minus 1 or something like that. I don't know. You probably wouldn't have thought of it that way, but the number of total ways minus the one right way would give me the number wrong. It makes sense, but yeah, I'm finding the probability of them failing on the first try, and now we want to find the odds of that. Yeah, okay, yeah, that's exactly the way you could think about it. Failure in the sense of they didn't get it right. Yes, this would be the F if you were thinking of that. So the odds of no guess is going to be 999 over 1,000 minus 999 is 1. But technically, failure in this case of them guessing is success in terms of the way this probability question was phrased, right? Because or you could view it as it's successful for our good friend Kim, who doesn't want her locker combination to be guessed. Right. So, all right, thanks for watching, Internet friends. Have a good day. Bye-bye.